Good evening. Welcome. I'm Kevin Marinelli, Executive Director of the Program for Public Discourse. The mission of the Program for Public Discourse is to foster civic virtue by promoting civil debate, demonstrating the power of constructive, agonistic dialogue and shared reasoning to explore and refine ideas in the public sphere toward the public good. Because whether you are a fierce advocate or a fierce skeptic concerning any issue or anywhere in between, we are all better served by engaging in good faith, robust exchange of ideas. Tonight's event, co-sponsored with the Steamboat Institute, continues our mission in the form of our Debating Public Policy series. Our topic tonight, is net zero by 2050 achievable and necessary to combat climate change, tackles one of the defining issues of our time. And we apologize to those who may have been expecting a debate on our previous topic of nuclear energy, but we promise nuclear energy will play a central role in tonight's debate. I also want to warn you of something right now. Tonight, you're going to be exposed to competing perspectives, sometimes contentious views. You're going to be okay. Participating in a debate like this does not make you a bad person. It doesn't make you complicit or guilty of platforming. In fact, to the very opposite, I would argue that your responsibilities as a democratic citizen is to sharpen your reasoning skills. And we can only do that by participating in the robust exchange of ideas such as this. Otherwise, those skills will atrophy, and we can't allow that to happen. So I'm very excited for tonight's event, and I am pleased now to invite Jennifer Schubert-Aiken to introduce our panelists.
Well, good evening, everyone. Thanks, Kevin. It's great to be here on the UNC campus. This is our first time for me and for our Steamboat Institute team to be visiting Chapel Hill, so we're really happy to be here. I went for a run on your campus this morning, and it was just beautiful. And I passed by a storefront. I saw a shirt, and I thought, after my run, I'm going to come back to the store because I want to get this shirt. Every time we go to a new campus, I like to get like a hat or a visor or a shirt to commemorate the visit to that campus. So I want to get your opinion on this shirt I bought this morning. Oops. Right here, we can see it. You like this shirt? So I thought you guys might like that. I'm a big sports fan, so I recognize and appreciate where I am. I truly admire what you've established here at UNC with the Program for Public Discourse, Kevin and Provost Clemens, and the Carolina Liberty Foundation. I'd like to give a shout out to Grant Leffler. Actually, we have something in common with you. One of Steamboat Institute's Tony Blankley Fellows, which is a journalism fellowship we have, is Hadley Heath Manning. She was Hadley Heath when she graduated from UNC, I believe, in 2012, and she was one of your Moorhead Kane Scholars here at UNC, and I think she just joined the board of the Carolina Liberty Foundation, so we do have a connection now with UNC, and we're really proud of that. Tonight's debate is the fifth stop in the fall edition of Steamboat Institute's Campus Liberty Tour debate series. We are visiting 6 campuses in 6 weeks, 6 different states. This is the 5th stop on the tour. So far this semester, we've visited the old Parkland Debate Chamber in Dallas. So it wasn't actually on a campus, but it was close to SMU. We had several students. We visited Washington and Lee University in Lexington, Virginia, with a debate on diversity, equity, and inclusion initiatives. We visited the University of Texas at Austin with another energy and climate debate, a little bit different from the one tonight. And we were at the University of Maryland last week doing a debate on environmental, social, and governance practices in investing that was really interesting. If you are interested in seeing any of those, all of those debates are on Steamboat Institute's YouTube channel. You can watch the whole thing or just certain parts of it if you want. It's all there for free, steamboatinstitute.org or the YouTube channel, so take advantage of that. And tonight's debate will also be available on our YouTube channel in about 3 days. I would also like to welcome our virtual audience. We have people watching from all over the country. I know we have a couple of watch parties which have been organized. There's a group of MIT alumni and a group of Cornell alumni, and there may be others, but we'd like to give a shout out to our friends from MIT and Cornell for hosting those watch parties tonight. So that's another thing you can always do if you want to get a group of friends together and watch one of our debates live. These viewers, as well as all of you in the auditorium tonight, will be able to submit questions to the speakers using the QR code. You will receive a text link, and there's also a QR code on the cards that you found on your seats. And those watching online can participate as well. I would also like to acknowledge we have some high school students here tonight who are part of a local debate program. The Calvin Coolidge Presidential Foundation sponsors a high school debate tournament, which is happening this Saturday here in the Raleigh-Durham area. The high school debate teams will be arguing tonight's resolution at their debate tournament on Saturday. So they're going to be listening carefully and taking notes tonight to use on Saturday, and I think some of them are watching online as well tonight. So we hope that they and all of you will see from tonight's debate how a complex and somewhat controversial topic can be discussed using persuasion, reason, and facts with an emphasis on critical thinking skills. We are proud, in partnership with the UNC Program for Public Discourse and the Carolina Liberty Foundation, to offer this shining example tonight of how civilized debate and discourse of our nation's most pressing problems is possible. As with all of our debates held on campuses all over America, the emphasis is on civility and how to think, not what to think. So you don't have to be nervous or apprehensive about sharing your opinion here, because all opinions are welcome. We just want you to listen and learn. As a nonprofit, nonpartisan organization, Steamboat Institute relies on the support of many individuals and foundations to bring programs such as this debate to audience all over the country. I would like to extend a special thank you to the Adolph Coors Foundation and the Diana Davis Spencer Foundation, two of our major supporters, for allowing us to expand this program to more campuses across America. Earth's climate is changing, but does that mean that net zero energy policy is necessary? And what exactly do we mean by net zero, and why is it such a controversial topic? Will it help to mitigate the effects of climate change, or will it only serve to drive up energy costs and make our sources of power less reliable? Tonight's program will examine this complex topic with a debate on the following resolution: be it resolved, net zero by 2050 is both achievable and necessary to address climate change. We invite all of our audience members here in the auditorium and watching online, vote right now using your phone if you haven't already. So grab your phone. You should have received a text message. You can vote agree, disagree, or undecided. So the more people who vote, the more representative it will be of the audience opinions, which it helps our speakers. And then again at the end, we're going to ask you to vote again to see if your opinions have changed. So this lets the speakers know who maybe made the more persuasive argument, but more about winning and losing, it's more to see if you have learned and found value in this debate, and that's what it's all about. So it's okay to take out your phones. You can vote. I think right now we're seeing 43% agree with the resolution that net zero is achievable and necessary, 44% disagree, 14% are undecided. So it'll be interesting to see how that changes by the end. Okay, so now I'm going to introduce our speakers and moderator for the evening. So I'd like to ask you gentlemen to come up on the stage and take your seats, and we will get this going. Skip. Okay, arguing the affirmative on tonight's resolution is Roger Pielke, Jr., seated right here. Roger has been on the faculty of the University of Colorado Boulder since 2001, where he teaches and writes on a diverse range of policy and governance issues related to science, technology, environment, energy, climate, innovation, and even sports. At CU, Roger is a professor in the College of Arts and Sciences. Most recently, he was on sabbatical at the University of Oslo, where he worked to help the university start a pandemic research center. Roger is also an honorary professor at University College of London, which was awarded last year. Roger also oversees a popular Substack, The Honest Broker, where he is experimenting with a new approach to research writing and public engagement. Roger is frequently called upon by governments, businesses, universities, sports governance organizations, and others around the world as a speaker and policy advisor. His research is widely cited in multiple fields. Roger's most recent National Science Foundation grant focused on science advice in the pandemic across the world. He's written or co-authored many books, including Hurricanes, Their Nature and Impacts on Society, The Honest Broker, Making Sense of Science in Policy and Politics, and The Climate Fix, What Scientists and Politicians Won't Tell You About Global Warming. Let's give a warm welcome to Professor Roger Pielke. Arguing in the negative on tonight's resolution is Stephen Koonin. Dr. Koonin is a leader in science policy, having served as Undersecretary for Science in the U.S. Department of Energy under President Obama. In this role, he was the lead author of the department's strategic plan and the inaugural Quadrennial Technology Review, which started in 2011. With more than 200 peer-reviewed papers in the fields of physics and astrophysics, scientific computation, energy technology, and climate science, Dr. Koonin was a professor of theoretical physics at Caltech, also serving as Caltech's vice president and provost for nearly a decade. Dr. Koonin is currently a professor at New York University with appointments in the Stern School of Business, the Tandon School of Engineering, and the Department of Physics. His memberships include the U.S. National Academy of Sciences, the American Academy of Arts and Sciences, and the Jason Group of scientists who solve technical problems for the U.S. government. He is the author of Unsettled, What Climate Science Tells Us, What It Doesn't, and Why It Matters. And since the book's release in April of 21, more than 200,000 copies have been sold. Let's give a warm welcome to Dr. Stephen Koonin. Our moderator for tonight's debate is someone that many of you know well. Chris Clemens is Provost and Chief Academic Officer here at the University of North Carolina at Chapel Hill. Dr. Clemens came to UNC in 1998 from Caltech, so I believe he and Dr. Koonin knew each other. He was a Sherman Fairchild postdoctoral fellow in astronomy. Previously, he was a NASA Hubble Fellow at Iowa State University and received his PhD in astronomy from the University of Texas at Austin. He also received a Bachelor of Science in Astrophysics from the University of Oklahoma, which is my alma mater. He is a dedicated mentor of graduate students and in 2012 received the Faculty Award for Excellence in Doctoral Mentoring. He leads an active research program in stellar astrophysics, exoplanetary astronomy, and astronomical instrumentation. In 2019-20, he led the effort to establish the Program for Public Discourse, which is co-hosting tonight's program. Let's give a warm welcome to UNC's own Provost Chris Clemens, and now I will turn it over to Provost Clemens.
Thank you. Thank you so much, all of you, for coming. It's good to see a good turnout here. Before we start, I'm reminding you again, respond to the resolution, but I also remind you to submit questions during the talk as they come to you, because I will have those on a pad here, and that's how we're going to do the Q&A through this portal that I have here. You've already been introduced to our guests, but I will take the time to do some recommendations of their work. Dr. Roger Pielke Jr.'s 2010 book, The Climate Fix is a great introduction to the public policy questions and issues that surround climate change. I will say for a natural scientist like me, who tend to get bound up a little in the truth value of climate change axioms, it's a valuable shift of frame. And if I can pull one sentence that would characterize the book, it's Dr. Pielke's paraphrase of the pragmatist Walter Lippmann, who said the goal of politics is not to get everyone to think alike, but rather to get people who think differently to act alike. I'm sure we'll hear more about that in a moment. Dr. Stephen Koonin, you've heard, was provost. I knew him in the way that any postdoc knows a provost. He would have been, I think, the most youthful provost in America at that time in the late 90s. His book, Unsettled, is more an assessment of the state of the science from a critical perspective. And for his skepticism, he has been branded a denier by some folks who are more skilled perhaps in rhetoric than the kind of measured and careful thinking that one learns to do in the Caltech culture. The summary statement of his book, which he provides, climate and energy are complex and nuanced subjects. Simplistic descriptions of the problem or putative solutions will not result in wise choices. My job as moderator is hopefully to start an argument. So I'll just remind Dr. Koonin, Steve, that Roger called you out in his review of your book for saying that climate models are not reliable in their projections of how the climate will change over coming decades, but then you claim with confidence that the net economic impact of human-induced climate change will be minimal, at least through the end of this century. We'll come back to that later. Our format will be 10-minute opening statements, 3-minute rebuttals, and then 40 minutes of discussion, starting with my questions and then questions from the audience, and 5 minutes of closing from each guest. I'll ask Roger to start with his 10-minute opening statement.
All right, I guess they're going to get my slides up. Let me say it's great to be here, my first time on the Chapel Hill campus. Beautiful, absolutely. I mean, Boulder's got a beautiful campus, but Chapel Hill's got a beautiful campus too. It's great. I'm going to jump right into it. I want to thank the host, Steamboat Institute, University, Provost, all the usuals, but I'm going to jump right into it so I can get to my comments. So here's those two books, and I encourage you. This is a debate. The debate's going to be entertaining. Hopefully it'll be fun also. The fact that we're all here, we're having this exchange, I really appreciate Dr. Koonin. So we're all winners before we even start. Our 10 minutes and then 5 minutes is not very much, so if you want to see two different perspectives, you'll find that Dr. Koonin and I agree on a lot of things, but you also find that we disagree on some things, and that's how the world actually works. So I appreciate the opportunity to articulate some of those differences today. All right, so I'm arguing that net zero is necessary. And in fact, I'm going to argue that Dr. Koonin and I actually agree on this point. If we wish to reduce the risks associated with altering the Earth's energy balance, then the net forcing associated with the emission of greenhouse gases must go to zero. That's simply a scientific statement. All else equal, reducing risks is a good thing. Now, I'm pretty sure our conversation is going to focus on this part, all else equal. Dr. Koonin will say, well, it's too hard, it's too difficult, it costs too much, we have other priorities, maybe we should do something else. And I'll focus on that. But as a starting point, I think we could agree net zero is necessary. And let me say at the outset, my goal, and this is just for fun, my goal is not only to convince you, at the end, I think Dr. Koonin's going to say, well, I agree with Roger, he was right. All right, so here's some basic, again, consensus stuff that Dr. Koonin and I will agree on from the wonderful Global Carbon Project. On the upper left, you see the emissions of carbon dioxide from the burning of fossil fuels. And on the lower right, you see the increase in atmospheric concentrations of carbon dioxide. What that means is that we are altering the energy balance of the Earth system. And I, like Dr. Koonin, agree 100% that, and this is a quote from his book, the growing ocean heat content is the surest indication that the planet has indeed been warming in recent decades. And if we want to stop that, we have to get to net zero. It's that simple. So why net in net zero? Why don't we just say zero? It's complicated, and it goes into some detail, but carbon dioxide stays in the atmosphere for a long time. It's like putting water in a bathtub. And if you keep your spigot on, eventually the bathtub's going to overflow, it's going to damage your house. But it turns out that the atmospheric bathtub has a hole in it where some of that carbon dioxide is removed. It goes into the oceans, goes into the Earth's surface, into plants and biomass. So net zero actually means, and this is a round number, an 80% reduction in carbon dioxide emissions from today's values. Some people might say it's 70%, some people might say it's 90%, but it's net zero. It's not zero. So again, that's a good starting point because it tells us the magnitude of the challenge. It's a massive challenge, a massive challenge. It's not 100% though, it's more like 80%. So these are I had this in my slides before the provost said this, and this is my biggest beef with Dr. Koonen's book. He says the science is insufficient to make useful projections. And then in the same book, he makes a useful projection. The net economic impact of human-induced climate change will be minimal through at least the end of this century. Well, I hope so. That would be great. But these two things can't be true at the same time. All right, net zero is achievable. So I'm going to let you in on a secret that is not widely known. The global economy has been decarbonizing for the past century. And I'll explain exactly what that means in a second with math. Achieving net zero is not about whether it is achievable or not, but about the timescale and the cost. Decarbonization of the global economy has benefits. In economics, makes us richer. In security, makes us safer. In access, it helps everyone around the world get to the level of energy services that we enjoy without thinking about. And also, it helps the environment too. I was once in a debate in England, and I started out by saying, all right, let's forget about the environment. Let's just talk about economic security and access. And the guy I was debating hit the panel. He was really mad. He said, all I want to do is debate the science of climate change. This is a much bigger issue than just the science of climate change. And again, I expect we're going to spend a lot of time talking about time scale and cost, not whether it's achievable or not, but whether it's worth pursuing. All right, I do this in a semester. I'm going to do it in 2 minutes for you guys. If you can remember this little mnemonic, this little sentence, you'll know everything there is to know about emissions reduction policy. People engage in economic activity that uses energy from carbon-emitting generation. I put that on 4 lines. We can turn those into variables: population, GDP per capita, energy intensity of the economy, how much energy we use per unit of GDP, carbon intensity of energy, how much carbon or carbon dioxide emissions are emitted for every unit of energy we produce. All right, those are some variables. It's called the Kaya identity because everything cancels out. It's an incredibly powerful, simple tool for doing policy analysis. Now, if there's one thing I'm known for from my book, The Climate Fix, it's something called the iron law of climate policy. And the iron law says if we put economic objectives in opposition to environmental objectives, guess what? The economy is going to win every time. If you're watching the news last week, Justin Trudeau in Canada rolled back some of their net zero initiatives. In the UK last month, Rishi Sunak did the same thing. When gasoline in the United States gets to $4 a gallon, guess what? The president, whether Republican or Democrat, freaks out and does everything they can do. They let some of the gasoline out of the strategic reserve to put those prices down. There is a natural political buffer on energy prices getting too high. I am not worried about that. There's the yellow vest protests in France. When people feel the pinch of energy prices, they react. All right, so let's go back to the Kaya identity, and I'm going to simplify it. I'm going to put together population and GDP per capita, that's just GDP, and I'll combine the way that we use energy and the way we produce energy, that's just technology. Right away, you see we have a problem here. If all we do is talk about emissions, we want emissions to go down, but we want GDP to go up. And if they're on opposite sides of this equation, we're working in different directions at the same time. So I'm going to do some math here. I can do this because I have a math degree. I'm going to put GDP over on the other side. And so this ratio of emissions to GDP, this is called decarbonization of the economy. We want this ratio to go down. We want emissions down, GDP up. So if this ratio is going down, that's a sign that our technology is improving. All right, let's look at real-world data. This is that metric. Goes back, you can't see it, starts in 1990, before climate policy was a thing, ends last year. Look at that. It's been going down since 1990. In my book, I have data all the way back to 1910. The world has already been decarbonizing. When we talk about reaching net zero, we're not talking about doing something new or different or changing direction. We're talking about harnessing a process that's already in place and making it go faster. We reduce emissions when the rate of decarbonization is larger than the rate of GDP. That's it. Here's more data for a number of different countries. This is pre-Paris, but you can see China, and it's the bump at the top there when it was building a lot of coal plants. You can see Fukushima, the effects in Japan. You see Germany going down quickly, United States and Britain. But this process is going on all over the world. Now, that dashed line is the 2-degree target, so those countries aren't at that level, no secret there. But the world is already decarbonizing. So when we're talking about net zero, we're talking about accelerating a process already in place. Now, here's why I'm pretty optimistic that we can do this. So on the left, that's the number of registrations of three-wheelers. So rickshaws, if anyone's been in India, if you've been in Thailand, the tuk-tuks, you're familiar. The amount of petroleum consumption from these dwarfs the United States cars and trucks. Teslas aren't where the action at. It's in where most of the people are in the world. But what you see in the bottom there, the blue is the total number of new registrations going back about a decade for three-wheelers in India. And the bottom is the proportion of those that are electric. So rickshaw drivers in India are choosing electric, probably not because they're thinking, well, this is good for the global climate and net zero, because it's cheaper, more reliable, cleaner. And so we can see already 50% are electric. On the right, this is installed capacity for electricity in China. And you can see the bottom is thermal, so that's coal and natural gas, and then the nice colorful things are carbon-free. All I want you to see here is that the ratio between the carbon-free and the carbon-intensive, the gray part in the bottom, it's getting closer. China is pursuing an all-of-the-above energy policy because they need a lot of energy. And yes, of course, they're still reliant on fossil fuels. But do you expect that trend to turn around? So my argument is we are moving in the direction of decarbonizing the economy. We should keep that up. Maybe we should give it a little boost. Now, some people say, well, it can't be done. We can never, this is Paul Ehrlich, 1968. The battle to feed all of humanity is over. I know that betting against human ingenuity and the ability to transform global systems, whether it's agriculture, medicine, or energy, people betting on the we can't do it side have routinely been proven to be wrong. Now, I don't know when we can get net zero. Nobody knows when we can get net zero. Here's a schematic I made. When can we achieve net zero? I got 2050 there on the near side. That's on the thin side of the bell curve. But I'm pretty sure we can do it by 2100 if we put our mind to it. And maybe if we put our mind to it, it turns out we can do it by 2050. Nobody knows. But I do know it's a benefit not just to the environment, but to many other things. And I hope that comes out in our conversation. Thank you for your attention. And I look forward to Dr. Koonen's remarks.
All right, now I'll invite Steve to give his 10-minute intro.
Okay, so we can get my first chart up. Okay, so there is the proposition. It's achievable by 2050 and is necessary to address climate change. Let's see, can I get the next slide? Okay, my short answer is no and no. Roger's answer was a little fuzzy, I think, maybe doable. I'm going to try to convince you that it is, in fact, no and no. What does it mean, first of all? This shows global emissions of carbon dioxide since 1750. You see the tremendous run-up that we've seen starting in about 1900. If you want to go to net zero, you got to do that to the curve. And that is an heroic, and I would assert practically impossible achievement. Yes, maybe 20% is okay at the end, but that's essentially what you've got to do. So, first part of the proposition, is it achievable? And I think it's good to talk about definitions for a second. Net zero, we're talking global net zero. If the US and Europe went to net zero, it would not have much effect on the climate. And second, achievable, well, it is achievable if we went back to life in the 18th century. But we're talking about achievable under plausible assumptions about politics, economics, technology, and so on. And let me tell you what I see as the barriers to doing this. The first is this chart, which shows how much energy each person uses per year plotted against the economic activity, or GDP, per year. And there are a whole bunch of countries in the upper right, including the US, kind of in the middle are European countries, and down on the bottom is about half of the world's population whose energy use increases steadily and almost universally as they get richer. Life down in that lower left-hand corner is not very pleasant. You're cooking with wood and dung. The indoor pollution kills 3 million people a year. You're studying by candlelight, not a very hospitable way to do your education. And the quantitative details are also astounding. The US energy consumption per capita is 30 times that of Nigeria. And there are about 3 billion people in the world of the 8 billion who use less electricity every year than the average US refrigerator. So think about that for a minute and ask yourself, how are we going to get those folks the energy that they need to improve their lives? Well, if we assume that they are going to improve their lives as expected, energy demand is going to go up by 50% over the next 30 years. And that means not only do we have to decarbonize the existing system, but we've got to build 50% more emissions-free. Right now, fossil fuels provide 80% of the world's energy. That's a condition that's been true since the beginning of this chart, which was in 1960, I guess, or thereabouts. Wind and solar, which are the current fashion, are two little bands in the upper right of that chart. The world has spent $4 trillion over the last decade to try to promote wind and solar, and it hasn't made much of a dent. Wind and solar by themselves cannot provide the electricity that the modern society needs because they're intermittent. You need to build a backup system that accounts for the sometimes weeks-long periods when wind and solar don't produce electricity. The cost of that backup system is more than the actual wind and solar itself, and so you wind up running two parallel systems. I think wind and solar is entirely misguided. Anyway, you see that we're going to need fossil fuels to get those folks the energy that they need. Another reason I'm pessimistic about the ability to do net zero by 2050 is that energy systems change slowly, even in the developed world. This is the US energy supply over the last 70 years, and you can see it takes decades to change. And there are good reasons for that. Energy facilities last a long time. They need to be very reliable. They need to be interoperable. The notion of an energy revolution is an oxymoron. The new energy technologies also take a lot of stuff. As you can see in the upper graph, an electric vehicle uses 7 times as much high-value material as does an ordinary internal combustion car. And if you look at electricity generation, onshore wind uses 9 times as much rare earths, copper, cobalt, and so on than does a natural gas turbine. So this is going to mean, if the energy transition proceeds at the pace some people think it should, a lot of mining, often in inhospitable places. So net zero by 2050 will be more disruptive than climate change itself, I would assert, because you're going to increase the cost of energy. Zero emissions, it's got to be more expensive than if you're allowed to emit. Costs are going to increase across society because energy touches everything. We're going to see a disruption in domestic employment, domestic behavior, domestic cash flows. We're going to see increased mining, processing, land use, energy waste, wind turbine blades. What do you do with them after they're worn out? And the cost is astounding. Independent estimates suggest that it's 3 to 6% of GDP for the next 30 years. In the US, that's $1.5 trillion. We could do a lot with that money besides decarbonize the economy for uncertain benefits. All right, I strive to rely, as you see, on authoritative sources, and in this discussion, I would commend to you a podcast that dropped about a month ago, which had Roger, Chris Wright, and Maynard Holt talking about these issues. It's a wonderful podcast, 3 very knowledgeable folks talking, and so it's interesting to see what Roger said in that podcast about whether net zero by 2050 is achievable. If you want to decarbonize a global society, he said, that's a century-long project. And then he said, I have no concerns that if the policymakers and the public understood the implications of a rapid energy transition, that the public would say, oh yeah, we're all in for that. We want more expensive energy and a lower GDP. It's not going to happen, said Roger. He said, no, I agree. So yes, I am winding up agreeing with you, Roger. All right, let me take the second point. Is net zero by 2050 necessary to address climate change? Necessary means you gotta do it. And address climate change, in my definition, is to best manage the energy climate circumstances we're in. There's the global temperature record, and since 1900, the globe has warmed 1.3 degrees. A comparable warming is projected over the next 80 or 100 years. And so we might look at how the globe has fared during that 1.3 degrees of warming. And the answer is we have seen the greatest flourishing ever of society. The population of the globe went 1.5 up to 8 billion people currently. Lifespan went from 32 years to 73 years. GDP per capita went up by a factor of 7. Deaths from extreme weather, the rate went down by a factor of 50, despite the fact that the globe warmed another 1.3 degrees. So at least there's good evidence that humans have tolerated the kind of warming we're talking about over the next century. Not guaranteed, because the future is uncertain. People worry about tipping points and so on, but we are a marvelously adaptable species. Here's the IPCC telling us that global warming will not be a catastrophe, that there are many other societally important things that will determine our GDP. And there's the Biden White House put out in March a chart showing the impact of warming on the US GDP. And forget the details, but the vertical scale is in a couple percent and the horizontal scale is in a couple degrees. Hardly a catastrophe. So, is net zero by 2050 necessary? Roger said in the podcast, climate futures today are much less apocalyptic than they were 5 years ago. And yes, climate change is a problem, he said, but it's not the end of the world. I think you said no, and if so, I agree. So, to sum up, there's the proposition. I would assert it is not achievable and it is not necessary to address climate change. So you should reject the proposition. Thank you.
Thank you, Steve. We're going to have a 3-minute rebuttal by Roger. So Roger, please return to the podium and give us your shot.
You said 30 minutes? No.
Yeah.
All right. So Dr. Koonin put up a picture to show the temperature increase from 100 years ago. So my grandfather, rest in peace, was born in 1923. Global population in 1923 was 2 billion people. The average human life expectancy was 35 years. So let's get in a time machine. We're going to have a debate. Should the world adopt a proposition that we can feed 8 billion people by 2023? And at the same time, we're going to commit to more than doubling global average human lifespan. It would be ridiculous. You'd say it costs too much. We don't know how to do that. We haven't even invented penicillin yet. It can't be done. How did that happen? The way that we achieved a century-long success in feeding the world and improving health around the world was through investing in innovation that came up with things like vaccines, public health policies, the green revolution, when we can produce much more. We feed the same amount of people on the planet today using the same amount of land that we did in 1950. If we went back to 1950, we would say, we don't know how to do that. One thing we know how to do really well as a species is innovate and deploy those innovations to making life better. I'm glad you put up my comments. The world is not going to decarbonize by making people poor. I guarantee it. The way it's going to happen is we're going to take on an innovation challenge in energy like we did in agriculture, like we did in health. And as we do so, not only us who are already rich are going to get richer, but everyone around the world who's learning by candlelight, cooking with dung, and so on. That's the only way this way works. If we want to use ever more energy around the world, we're not going to be able to rely on fossil fuels. Right now, the world consumes 100 million barrels of oil a day. All right, let's just project that to everybody on the planet. That's 170, 200 million barrels. What do you think the price of oil is going to be if it goes up by 2 million barrels? It's going to go up to $150 a barrel. This is one reason why countries are moving to alternative sources of energy. It's economically beneficial. If you're Germany, and I think we would agree Germany has not been smart in their energy policy decisions, who decided to rely on Russian gas and shut down their nuclear power plants and keep their coal power plants burning. How does that look today? Boy, keeping those nuclear plants open might have been a much better option. As we look to the African continent and the tremendous surge in energy consumption that's going to occur over the next decades, that could be fossil fueled, or it could be nuclear, it could be natural gas with carbon capture and sequestration, it could be powered by Chinese companies, the Chinese government, the Russian government, or the United States could say, you know what, we're pushing for this net zero. We want good American jobs. We want people trained in American universities going there and implementing that. So there's a lot of reasons why pursuing this innovation challenge makes a lot of sense. Thank you.
Right, thank you, Roger. Steve, you will have the last word in the opening round.
Good on this one. I will forego commenting about economic and climate models, assuming we will get to that in the discussion.
I'll provoke you in a minute.
Sorry?
I'll provoke you in a minute.
Yeah, of course. Good. You know, Roger showed some things that superficially look pretty good, but you have to be careful. So he showed you the decarbonization of the globe and that the ratio of emissions to GDP was going down. That's true. But unfortunately, the climate cares about the absolute amount of emissions and not the ratio to economic activity. And that's been going up. We keep emitting more and more. In fact, we've seen record coal consumption and gas consumption in India and China the last few years. It's going up because they need the energy and your iron law, if you like, all right? Rickshaws in where was it, Thailand or India, right? That's great, all right. But you can be sure that people are not going to be content with rickshaws. They want automobiles just the way we do. It's not enough to have something that doesn't match Western standard of living. And when you get to electric vehicles, there are problems. I don't own an electric vehicle now, and it'll be a long time before I buy one, not because of the charging problem, and not because of the cost. I can afford it. But there are safety issues with the batteries, and the residual value of an electric vehicle declines very rapidly because the battery wears out, and it's a major part of the cost of the vehicle as a whole. So, you know, we're not there yet with all of this stuff, and it's going to take some time. I'm all for innovation. I agree with Roger. You know, we're going to solve these problems by innovation, but an innovation not only in energy technologies, but in adaptation. And we're very good at adapting. And so human ingenuity will be applied to that as well. The notion that energy innovation will bring jobs, I think, needs to be also taken with a grain of salt. When I was in the Department of Energy, I kept reminding people of this. Where a technology is invented versus where it's manufactured versus where it's deployed are three different things. And if you don't believe that, just look at solar panels. Invented in the West, US, manufactured these days in China almost exclusively, and deployed around the world. And so you got to be careful when you equate energy innovation with jobs. And then finally, Roger, you showed China's generation capacity as opposed to actual generation. And as people may or may not know, the renewables tend to operate at pretty low capacity. A number I carry around in my head is a third for wind and a quarter, a fifth for solar. So you really should be looking at the generation. Most of China's generation is coming from coal. All right, thank you.
Thank you, Steve. All right, so I have a couple of questions because I think we didn't get to a couple of topics I'd like to provoke out of you. And I'll start with Roger. First off, we didn't talk about the sequestration of carbon. I like your innovation argument. This is a university that believes in innovation. We encourage it in our students. Tell us about the kinds of innovations you think, because the story you tell is a great one. Norm Borlaug is down in Mexico developing a dwarf wheat that winds up saving 2 billion people from starvation. It's a great innovation story. What do we need if we're going to get there, even if it's 100 years and not 50? What does that look like? What should we be doing at this campus?
Yeah, so in my book, I call for a stance of what I call technological agnosticism. So energy policy is, going to get undressed here.
We'll get you back on.
Yeah. Energy policy is a lot like NFL football. Everybody has their favorite team. I like wind, I like solar, I like carbon capture, I like nuclear. And they go online, they fight with each other. We don't know where the successes are going to come, where the breakthroughs are going to come. So we need a broad base of investments in innovation. I don't know if carbon capture and storage will work at scale. You don't know either. None of us do. So the way we do this is we invest in research like government laboratories, universities, but we also have public-private partnerships. We deploy these, we test these in the real world. In a few years, I don't have grandkids yet, but probably coming soon, my grandkids are going to say, Granddaddy, what did you do in the great light bulb war of 2011? You guys probably remember it was political. Michelle Bachmann in Minnesota was talking about the squiggly little light bulbs. They're going to take the light bulb out of my cold dead hand. All that. We don't fight about light bulbs anymore. Why is that? Go to Home Depot. There's a whole wall of LEDs. They're just fine. You want bright light, not bright light. It lasts a long time. Innovation solved that problem. So invest in a broad portfolio, see what works. The things that are working, pursue those. The things that don't, maybe we diminish those.
All right, thanks. Now, Steve, suppose one of our bright undergrads or grad students comes up with a technology that has a cost to sequester carbon or to get rid of it in some way. The cost is comparable to the projections that you showed on the GDP for what we think warming will cost us economically. Should we make that investment if it's promising, or is it a fool's bargain because we could spend the money on something in an adaptation fashion and not worry about the carbon? What's the balance?
So I'm all for innovation. But when I got into BP, I was an academic and I get into this big company, and I'm asked to help guide their energy innovation. And what caught me up short almost from the first month is that energy innovation is different. It's not like tech. It's not like biomed where you can change things in a couple of years. It takes decades. Even to demonstrate something, you have to put down $1 billion, let's say. And that's just to do one. And as importantly, we already have pretty good ways of producing energy. And so whatever you invent has got to be at least as inexpensive as what you got already, except for maybe the added benefit of reducing emissions. And by the way, reducing emissions has no direct benefit to the consumer. Maybe long-term it prevents the climate from changing, maybe, but it's just different. And many people who've been entrepreneurs have said, I got the greatest thing, and then you run up against the real world, not to mention permitting and getting public acceptance and so on, which have killed many good ideas, including nuclear power.
Well, I'm going to run with that because that was my next question. Let's address the elephant in the room, and let's fulfill the promise of those who thought they were seeing a nuclear energy debate, which was our original topic. We have a technology. I'm proud to say that the electrons moving around and coming out of the wall here from Duke Energy are 50% generated by totally carbon-free nuclear energy. There's planned future investment. Why wouldn't we just say, go all nuclear? We're making batteries that are going to run cars. We can make electricity with nuclear. It runs. We know how it works. We have small power plants on ships for 70, 80 years. Why don't we just do that? Why wouldn't we put all of our money on a Manhattan project for slow nuclear fusion?
Fusion or fission?
Fission, I'm sorry. Fission. I should have said. We'll come to that in a minute, too. Yeah,
Ready to go?
Fission reactor. Why not?
Yeah, and I tell this to my students, I wrote this in my book, I cannot do the math of deep decarbonization without a big role for nuclear. And the actual truth is the world is going in on nuclear, not everywhere. Georgia, the Vogtle plant just started, but we're not going to have a new big conventional plant in the U.S. for a while. But there are plenty of places, UAE, South Korea, even Sweden is looking at nuclear. There's going to be more nuclear. People say, well, nuclear costs too much. Well, we built globally like 400 and some nuclear power plants. That's not a lot. I mean, if you look at how the cost curves are driven down, yeah, tell me how much they cost after we build 7,000 of them. So we haven't even started on nuclear. And I suspect this is one where Dr. Koonin and I are going to be probably in strong.
Well, I'm going to come to him, but I want to push you on one thing. You are actually as much a public policy expert as you are a scientist. And I think he just said the right thing, which is the barrier to nuclear energy is only a policy barrier around safety, around other issues. Why haven't you written us a book on that policy problem? Because we'd already be on our route to net zero by 2050 if we scaled that.
You know, the issues with nuclear, I just say, and it's perfectly legitimate for people to be afraid of nuclear power. Perfectly legitimate. And it's also legitimate for people to be afraid of climate change. But if you're afraid of both, then you got a math problem there. I am very optimistic because the students I teach, they say to me, like, why were we concerned about nuclear power? All I hear about is, climate change and existential threat. Why aren't we all in on nuclear power? And I do think there is a legacy of atomic bombs, atomic power, the Cold War, fear of nuclear waste, and people are afraid, and that's perfectly fine, but we have choices to make. And there are going to be some countries, if you're in an African country that's developing and the Chinese government comes in and says, we're going to give you financing, expertise, and we're going to build you a nuclear power plant, and it's going to cost this much, are you going to say no? Probably not. So I think the world is going to be seeing a lot more nuclear going forward. And my push is, well, maybe we should have American companies, American experts in on that as the world transforms its energy system, because it is going to happen.
All right. You want to say something about nuclear power?
Yeah, so, I'm trained as a nuclear physicist, and so the atom is my friend. When I was in the Department of Energy, I helped get the research program on small modular reactors going. I agree with you about the importance. I think the future is in small ones. We build them in a factory, come down the learning curve. I still have concerns about control of the fuel, non-proliferation issues. We need to work that out. Spent fuel, I think, is a solved problem. So, yeah, I would agree with your students and say, why not? Why aren't we doing this?
Okay, good. Now I'm going to go to audience questions. Although at some chance, we're going to give you a chance to resolve your contradiction. You almost, I think you laid the groundwork. We'll come back to that.
Okay.
But I have a couple of questions here that I want to get to from the audience. The first one is about solar, and it's for you, Steve. Mm-hmm. It's easier and cheaper to install off-grid solar. The prices are insanely good over a 10-year period. Mm-hmm. And mini-grid applications for underserved places like Nigeria are places where it's easy to do this without having a whole power grid. Or do you think it's easier to put in fossil fuel plants over there that are highly volatile in the market with energy costs. Which is a better option for a developing economy where you have no distribution?
There is no one good answer because circumstances are different. But what I can tell you is that a modern society, if you want people there to get beyond being able to read at night with solar power and to have a really modern economy, you're going to need central power plants. And, you know, the World Bank systematically refuses to fund fossil projects. Coal plant, for example, in Vietnam, I think, oil pipeline somewhere in Africa. They will just not fund it at all because it is carbon emitting. And of course, the Chinese will step in and do it anyway. And so I think, again, you want a modern society, you need a lot of reliable 99.99% electricity.
Okay. I have some questions at a more fundamental level that I think would be interesting to either dispel or at least find out where we are. A lot of folks are asking, how is it, well, first of all, how well established is it that the CO2 increase in the atmosphere is human caused? I think that one's easy. The other one is, how is it a fact that most of the CO2 is caused by humans, and how do we know that it's not just a correlation with temperature rather than a causative agent? How firm is that connection?
I'll defer to Steve. He talks about this in his book.
I just taught this actually on Monday night to my climate science class. There are 5 things that strongly suggest that the CO2 is human caused. One is the timing. We see the CO2 go up as fossil fuel use took off, starting in 1850, roughly. The second is the magnitude. How much stuff is up there is within a factor of 2 about what you estimate from fossil fuel emissions. The third is that, gosh, now I'm trying to remember what the third one, northern hemisphere versus southern hemisphere differences. Most of the fossil fuels are burned in the northern hemisphere. The concentration of CO2 as measured in Hawaii, for example, which is 20 degrees north of the equator, is a couple of ppm larger than it is if you measure at the South Pole. The fourth one, which in my mind is most convincing, is the isotopics. The carbon in the atmosphere is light, namely it has a little bit less carbon-13. Biological material is light, and so it's biological carbon that is getting injected into the atmosphere. And
so
the
that signature is distinctive,
yeah.
that it's fossil fuels being...
We actually see the oxygen going down just a little bit over the last 30 years because with burning carbon, it requires oxygen, and so the atmosphere is losing a little bit of oxygen, but we're not going to suffocate anytime soon. Small decrease.
Okay, well, I'm going to turn to Roger on some of that. So I think everyone agrees on those points. There are those, and I think you mentioned it, Russia as an example, who say, the increase in carbon dioxide increases plant growth. We've certainly had better yields with the fertilizers from petrochemicals. Are there benefits? Should we even be counting it only on the cost side? Is there another column that might balance this, which would support Steve's argument that it's not even necessary to do anything?
Yeah, so change by its nature has costs and benefits, and we project the future, and it's uncertain. And sure, I mean, the late Steve Schneider, climate scientist, said, the frustrating thing that about climate science is we don't know and we can't know in the long-term future whether the human-caused influences on climate will be minor or they will be catastrophic. It's a risk management problem. And so one thing I do know is that by eliminating that forcing, we also eliminate the risks. Do you want to, we do a pretty good job of growing food right now. So if you say, well, we need more carbon dioxide in the atmosphere so we can grow more food, we don't. We're doing great on crop product. Do we need to continue investing in agricultural research? For sure we do. So those benefits are those that are not unique. So we can get those in other ways. The risks, however, we may want to take those off the table. And I know there are some people who say, you know what, don't worry, everything's going to be fine. I'm not worried about it. That's fine. But for most people, the idea that we are altering the energy balance of the Earth system, that's kind of a thing, and we might want to stop that if we can do it at the same time, we're growing the economy, we're providing energy access, and we're making it more secure. And so I can take the environmental arguments off and make a pretty compelling case for almost the entire decarbonization argument.
So what you're saying is there's an unknown element to this risk. And while we may not be able to project catastrophe, it is a possibility. And really the rate at which carbon dioxide is increasing is kind of unparalleled in the records.
Yeah, I mean, here's a difference in perspective from like a policy perspective, from a scientific perspective. Scientists often want to predict the future. And from a policy perspective, we want to make the future. And so, scientists can argue all they want about what's going to happen in 2100. I'm not going to be here. Most of you won't be here. But what I do know is that if we eliminate that forcing, all right, that risk is off the table. We don't have to worry about that. And so for me, that's a very compelling argument. Again, it gets you to the starting line. It's not the end of the argument.
Did you want to say something in response?
Yeah, it is a risk mitigation discussion. You cannot, in real life, mitigate all risk. I'll give you an example. I flew down here this morning on an airplane, and Roger flew in from London. There was an existential risk that both of us took in doing that, but we judged the risk small enough compared to the benefits that it was worth taking. And you have to look at the countervailing issues. You can't just say, yeah, let's reduce emissions, because you need energy access and you need energy to run an economy. And so it really is a weighing of those various factors.
Yeah, I mean, I just say that flying is safe because we've taken proactive steps to eliminate the risks of flying.
Not eliminate, but reduce.
It's pretty safe. But I mean, look, so the 737 MAX, a couple of them fell out of the sky. And if we were having this debate, you wouldn't say, well, you know what, things are pretty safe, and it's going to cost a lot to make them safer. No, we looked at it and we put in fixes. And that's how innovation happens. It happens little by little for a real long time, and all of a sudden, your system is transformed. If you look at airplane safety, flying safety in the 1960s compared to today, it was a completely different world.
Yeah, of course.
I have a question here about electric cars. So Steve, you already convinced me it's an economic negative for me to buy one. But let's talk about the environmental impact. Both of you talked about them, and you used them in one of your examples, but the electricity is coming chiefly from fossil fuels. So you've moved the site of burning somewhere else. And then you have these other environmental impacts. So forget about the personal economic equation. Should we be pursuing the mass electrification of the transportation industry as part of our climate strategy?
Well, if you want to eliminate vehicle emissions, get started on electrification of the fleet now with the expectation, whether realistic or not, that the electricity system is going to decarbonize simultaneously. But there's another issue with the electric cars which isn't talked about too much. And that is, it's not so much a question of energy. It's only, I think, about 30% more electricity to run the whole US light-duty fleet than we're generating now, but it's power. And if everybody plugs in at the same time, you've got to bolster the distribution system, all the wires that run under the streets or overhead, the transformers and so on. That's a massive build-out, particularly in a place like Manhattan, where it's all underground. So the Con Ed guys in Manhattan are scared to death of having to bolster the distribution system, not only for the cars, but for building heat as well.
Yeah, so what I'm hearing is it's difficult, but if you're on a path to decarbonize the electric system, build that now, because that part you can do. That's sensible. All right, Roger, any further comments? And talk to me about lithium. We have a large lithium reserve in North Carolina. Environmentally, are we making a false trade when we start doing these lithium?
Yeah, what came into my brain, and I can date people here, like how many of you saw Michael Douglas in Wall Street in the 1980s, the slick back hair and the suspenders? All right, you remember the phone that he was talking on? It was like a big brick. All right, we have these now. The electric cars of today are the phones that Michael Douglas was using then. Yeah, they're expensive. They're not as perfect as we would like, but the idea that this is the end point of innovation in electric cars, and I don't know what's true or what's not true, but I'm reading about Toyota building solid state batteries, the next generation that can get 1,200 kilometers on one charge. Is waste a problem? Is recycling a problem? Of course it is. We've got 8 billion people on the planet. This is what we do. Is waste of your cell phones and your computers a problem? Yeah. Do we deal with it? Yeah. So my view very much is that we are in the early days of electrification of transportation. And so long as it continues to improve, it's cheaper, more reliable, and reduces costs to the end user, it's going to continue to expand. And we see this in all areas of technology. And I don't know why we would think, oh my gosh, in 2023, we reached the peak of our energy system, and we're not going to worry about it anymore going forward.
Steve is not liking your analogy.
No, I don't like your
and
analogy.
So I want to know why this analogy is
because
not good with
Michael
iPhone.
Douglas's phone, even then, and even more so today, provided a service that he couldn't get anywhere else. And so there was a great incentive to improve things. You could watch the traffic, look things up. I mean, all the things we do with phones now. An electric car does not provide much in the way of new service. Yes, you don't have to visit your mechanic hardly at all, but you've got other downsides. And so, people, we're seeing a fall off in electric vehicle sales, as you probably know right now. Ford is losing a tremendous amount of money trying to push electric vehicles, as is GM. So it remains to be seen whether there's going to be that consumer pull or not.
Yeah, and I would be careful extending what's happening in the U.S. market with the big automakers to what's happening globally. The data is that Tesla is great, and the Ford F-150 looks like a great vehicle, but that's not where the action is worldwide. There's 7.8 billion people outside the United States consuming energy, and there is a pretty sharp shift in a lot of these places to technologies that people just think are better. And again, the market will decide, but the market is interspersed with how we decide to invest in innovation and the policies we put in place to accelerate innovation in the marketplace.
Well, let me go back to a part of the question you didn't answer. In your book, you talk a lot about not just thinking about carbon. That's the simple one. If you take it out, you're negating the fact that we put it in. But you talk about the broader environmental impacts. We've had problems with coal ash in North Carolina. We're talking about developing lithium mines again. Which should I worry more about, or is lithium something we can extract cleanly and continue to, because we're going to need a lot of these raw materials for electric cars, as was pointed out.
Yeah, to start at the very beginning, we move a lot of earth already today. The fossil fuel powered world requires a lot of mining, a lot of digging, a lot of extracting. If we're going to have an electrified world, we're going to have a lot of mining, a lot of digging, a lot of extracting. And would it be better if we required less of these rare earths? If these rare earths were located in places that are secure and reliable? Of course. And that'll be the policy imperatives. And so these are the choices that we make in innovation policy. Steve said something that I think was really important, was that the supply chains for solar panels, for example, go through China. That's not a natural thing that happens out in the world. That's a result of policy. That's a result of decisions that we make in our energy system. So the case I'm making to you is let's treat energy with the importance that it deserves. It's not something that the quote unquote free market takes care of. We want it to be secure, clean, reliable. And to do that, we need to make decisions intentionally so that we do locate the lithium mines in California or North Carolina or wherever it happens to be. And at the same time, we're pursuing policies. Can we build these batteries with less lithium or something that we don't need so much of? And again, the history of innovation is not that we can predict everything with complete certainty, but we know how to take the next step. And that's the argument I'm making, is that everyone's focused on, and this is the problem with net zero, everybody's focused on the last ton. I'm focused on the next ton, and then getting the next ton after that faster, and then getting the one after that even faster. That's how we get to net zero.
Okay. We're getting a little short on time, and I promised Steve I would come back to What I think is a theme that we can both address here. There's been a little bit of an idea that risk management means avoiding the catastrophe by getting to net zero. You're not that concerned about catastrophic scenarios. In fact, even without a reliable model, you're claiming the impact is nil. How do you resolve that?
Not is, but is likely to be.
Yeah. So how do you resolve that apparent contradiction he's pointed out now?
So, so let me talk about the climate models a bit first.
Yep.
Okay? And I take my cue from what has been said in print and said privately by two of the premier modelers, Bjorn Stevens and Tim Palmer. You may know them both. You'll agree they're quality guys. In public, they would say the models that we use give us only a hazy picture of what happens globally, and they're just not fit for purpose at a regional level. In private, Tim has said in an email to Academy members, the models are useless almost at, I'm not paraphrasing here, I have the right exact word somewhere, at the regional level. They can't even predict, as the IPCC shows, the precipitation change, whether it's going to go wetter or drier at the regional level. And when we modelers point that out to the policymakers, they prefer that we not do that because it undermines the case for immediate action. So that's the climate models. Let's talk about the economic models and ask, why do I believe them more? One is, of course, experience already that we have adapted just fine. The other is that the economic models tend to be done as a function of temperature, not as a function of forcing. And so they'll get the temperature rise a little bit wrong here or there, but it's pretty smooth. And they all agree it's a few percent impact for a few degrees. There are no outliers except for people who use demonstrably wrong prediction methods. You'll probably know the Burke work.
So let me try to summarize that. You're saying even without a model, experience teaches that we have a bound on that, and going forward, that bound will maintain.
It doesn't matter exactly what the numbers are. As a physicist, you will appreciate the reasoning. It doesn't matter whether it's 0.5% or 2%. The point is it's small.
It's not catastrophic.
That's right.
Yeah. Now, all of that assumes there isn't a tipping point. Now, I just want you to know that many young people, I talk to them every day, and you teach them too, believe firmly that there's this tipping point that might be very close, and that they're angry at our generation for wrecking the planet and in despair over the fact that they even have a future.
So let me just address tipping points. There's a paper by Dientz et al., including this guy Wagner that we talked about. They look at 8 different tipping points, including the slowdown of the Atlantic circulation, permafrost outgassing, Amazon drying up, and so on. And their estimates, again, peer-reviewed PNAS literature, couple percent additional, less than 2% additional by these tipping points. So again, it's not 10%, it's not 30%, it's a couple percent. Now, you could say it's only a bunch of economists making estimates. We don't know what the real answer is. But right now, the scientific community does not see a big economic impact from these tipping points.
Or I take it health. In other words, we've adapted so far. We'll continue to adapt.
Yeah, it's the same ingenuity argument that Roger was making about innovation.
So it's okay for me to turn the attention of young people to the killer asteroid that could hit it?
Turn the attention of young people to getting energy to the 50% of the planet that doesn't have it.
I like that answer. Go ahead, Roger. I know you.
I just want to say, I mean, again, this is different between a policy perspective and a scientific perspective. Here's an analogy, quick analogy. You got some kids in the basement. They're playing with matches. Lighting little pieces of paper on fire. Do you go out and say, I'm going to get some experts. Can you give me a modeling estimate to the chances that that actually goes and burns down my house? Could be a tipping point. The whole house could go up. No, you go down and you say, hey, you kids, stop doing that. There, you made a decision, problem solved, no risk. So I don't believe, I'm probably very similar to Steve, that we can accurately predict what's going to happen in the next 100 years. But that means I don't believe the predictions that everything's going to be fine either. We assure our future by making decisions. You want to have enough food? All right, let's make decisions so we can grow enough food. You want the lifespan to be 80 years, 85 years? Okay, let's make decisions so public health is improved and medicine is improved. We make decisions. We don't bet on the good outcome.
All right. Well, with that, I'm going to remind everyone that we have a post-debate poll. I'd like you to go now with the code, and we're going to have a chance to sum up in 5 minutes each. And Roger, I'll let you take the podium and give us your summary of what you think the takeaway is from tonight's debate in general.
All right, so my first takeaway has been great fun. Thanks, Dr. Koonin. Thanks to the organizers. Hope you guys had fun. Hope you learned something. For me, the issue of climate change very early on became, quote unquote, scientized. We turned it into a debate about what does the science say? And let's get certainty on the science, and that'll tell us what to do about the future. And then all of a sudden we got hooked on, well, carbon dioxide, that's the fulcrum on which energy policy decisions should be made. And the environmental community is as guilty as anyone for having that narrow focus. What I'd like to end with tonight is that energy policy, energy is the policy. Energy is essential to everything we do in life. And we treat it differently than we treat agriculture and public health. The world has been decarbonizing. And there's a good reason for that, because it makes us richer, makes us safer, makes the world cleaner. A big part of that is efficiency gains. Companies love efficiency gains. Big part of that is not digging big holes in the ground and producing coal ash. One of the biggest killers around the world is air pollution from the burning of stuff, including fossil fuels. So there are good reasons why the world has been decarbonized, even in the absence of climate policy. So the argument I would say is, all right, let's take a look at that background trend. Are there things we could do to accelerate that trend, to improve our economics, improve our security, improve the environmental consequences as well? And the answer is yes. There's plenty of things. So I am arguing for a much broader approach to thinking through energy policy. And once we do that, we realize that decarbonization, net zero, sits on a chair with at least 4 legs, maybe more. And so narrowly arguing about climate change isn't going to get us very far. And guess what? The rest of the world is moving on energy policy, not because of the Paris Agreement, not because of the environment, because it's smart. They want more energy. They want cleaner energy. They want all those tuk-tuks running on batteries. So anyway, I think we'll stick around after. Happy to chat with people. And thank you for your attention. It's been a lot of fun.
Good. Could I get my last couple slides up? Let me just say while we're fooling with that, I have greatly enjoyed the dialogue, and it's been a lot of fun. Okay, look, the world has been pursuing, and I think it really is aspirational at this point, because even Al Gore admits it's not going to happen. John Kerry admits it's not going to happen. Net zero by 2050. It's already proving harmful. We're abandoning crucial energy technologies before viable alternatives are already available. Contrast what the US or Europe is doing with President Xi in China, who says we're not going to give up our existing energy system until we've got something that is a suitable replacement. It's being pursued, Texas, California, certainly Europe, in ways that degrade reliability and increase costs. It's being pursued at the expense of other, more certain, more immediate, and more soluble problems. Energy poverty, health, education, defense, wonderful ways to spend 5% of GDP. And then finally, it's been pursued by scaring young people that you mentioned already. We're depressing them as well. I like the term climatosis, and it's only in the West. If you go to China, you go to India, other countries that are developing, you don't see this depression and fear. So I've spent a lot of time telling you why it's not going to work. Let me tell you what I think we should be doing going forward. Cancel the climate crisis. Anybody who uses those words should be shouted down. But at the same time, we should acknowledge the task and the challenge of reducing human influences on the climate. We really need to educate non-experts and decision makers about the nuances of both the climate and the energy story. We need to continue the climate science. We're looking for small shifts over decades, and we need to continue the observations and do a better job of understanding and modeling. We need to acknowledge, it's a version of your iron law, that reliability and affordability come before reducing emissions. You're not going to reduce emissions until you've got reliable and affordable energy. Do not constrain the developing world. It is immoral to do that. And put a greater focus on adaptation. We don't have a good framework. We don't have good estimate of costs yet. And help the developing countries become resilient enough so that they can adapt. Technology is the way one is going to get out of this issue if we do at all. I like fission, grid storage, batteries, non-carbon chemical fuels. We haven't talked about fusion. Maybe we can do that at some point. It's a fun discussion. And then finally, because energy is so interwoven with everything in society, you want a graceful decarbonization plan that respects technology, economics, business, regulation, behavior. Nobody has put forward such a plan, to my knowledge, whether it's the National Academy or other studies that have been done, the corporations and so on. I think that's a thing that's well worth working on. Thank you.
All right. So I'll just disagree with one thing. We're not going to shout down anyone who says climate crisis. Our style here is to argue it out.
All right.
And so I hope we have had some useful argument tonight. Do we have the results of the post poll to put up, or are they supposed to be on this? We'd like to see if anything has changed.
If you've not voted yet in the post-debate poll, get your vote in now. We had over 100 people voting in the first one. So it looks like we've got changing a little bit. So you can see your votes are counting. You can see it right in front of you. So pre-debate poll, we have 43% agreed with the resolution that net zero is achievable and necessary. Right now we're at about 5%. It's fluctuating a little bit that now agree. So it looks like also the undecided has declined a little bit from 12 to 10%. So it looks like opinions have shifted to say that fewer people now agree with the resolution. Is that a fair assessment?
I would say that's fair, and I'm going to guess, though we didn't tear apart the logical and, that more folks are worried about achievable than necessary. I think I was persuaded by quotations from his opponent that a part of what's going on here is Roger is taking a position to drive innovation that he will struggle with himself over sometimes when 2050 is really close. And so the achievable part is getting harder and harder. And so I think that's the thing where I might have moved a little toward hoping for the innovation, but some more discouragement that it can be done. On the necessary, I don't feel I moved as much, and I'm guessing the audience still has a fair number of people who think if we don't do it, some bad things. Well, true enough.
That was a proposition.
True enough.
Right?
It may be that that's moved as well based on the date. So I think it's interesting to see this as we do this in class, and we're always happy when the conversation refines people's thinking a little bit, and this is definitely a change. So thank you all for participating in that poll.
Yeah, it's a round of applause for a great discussion. Just very, very brief closing remarks, and then we're going to go out in the foyer, and the Program for Public Discourse has pizza. So you got to stick around, and you'll have some free pizza, courtesy of Program for Public Discourse, and visit with our speakers. So once again, thank you to the Program for Public Discourse, to the Carolina Liberty Foundation. Also, I'd like to extend a special thank you to the Adolph Coors Foundation and the Diana Davis Spencer Foundation for supporting Steamboat Institute's Campus Liberty Tour. We are a nonprofit, nonpartisan organization. We appreciate your donations to keep our programs going, so you can visit steamboatinstitute.org. Thanks again for coming.